Today we'll be solving the AS Biology practical paper of October-November 2023, variant 4. The first question shows the progress of some enzyme catalyzed reactions can be followed by measuring the time taken for the substrate to be hydrolyzed. The enzyme amylase catalyzes the hydrolysis of starch to maltose. You will investigate the effect of different concentrations of amylase on the hydrolysis of starch. You are provided with the material shown in table 1.1. So the independent variable in this investigation is going to be the effect of different concentrations of amylase. So table 1.1, you will be provided with E, which is 2.0% concentration of amylase solution, S, which is 1.0% concentrations of starch solution, W is distilled water, iodine is the iodine solution, and U is an unknown concentration of amylase solution. If any solutions comes into contact with your skin, wash off immediately under cold water. It's recommended that you wear suitable air protection. Question AI states that think about the hazards of using the materials in table 1.1 and decide whether the risk of using ES and iodine is low, medium, or high. So your answer should be low, medium, or high using the word. So complete table 1.1, and you may use each word once, more than once, or not at all. So the first one is that the amylase solution is an irritant, so any irritation, the risk of it is medium. And then the 1% concentration of starch solution has no hazards, none, so the risk is low. The iodine solution is an irritant, so the risk is at medium. You'll need to prepare different concentrations of amylase solution, record the time taken for the amylase to hydrolyze starch, and use your results to estimate the concentration of an unknown solution of amylase U. You will need to use proportional dilution to make different concentrations of amylase solution. You will need to prepare 10 centimeter cubed of each concentration using E and W. Table 1.2 shows how to prepare two of the concentrations you will use. Decide which other concentrations of amylase solution you will use. The question II gives us the table 1.2 and the first percentage concentration of amylase solution given to us is 2, which has 10 centimeter cubed volume of E and 0 centimeter cubed volume of W, no water at all. And the last is 0.4, which has 2.0 centimeter cubed of E and 8.0 centimeter cubed of W. So you can create the concentrations by decreasing 0.4%, 2.0, 1.6, 1.2, and 0.8, 1.2 and 0.8, and the volume will be decreasing by 2, 8, 6, and 4, and the volume of W will be 2, 4, and 6. And don't forget that both the volumes should add up to 10 centimeter cubed as indicated here. During the investigation, you will be sampling at intervals and using iodine solution to test for the presence of starch. The endpoint is reached when the iodine solution is a dark yellow-brown. There may also be some specks of blue-black present in the iodine solution. These specks can be ignored. Carry out step 1 to step 14. You have to read the steps carefully. And the one important thing in the steps that the numbers indicate the sampling time in seconds. These numbers, which is 15, 30, 45, 60, 75, 90. These are the seconds. So when you're going to plot the graph, the table, and record the results in it, your results in seconds has to be one of the values given in this table. So you can't write like 74 seconds, it has to be 75, 105, 150. So record your results in an appropriate table. Of course, read the steps first. The left side is going to be the independent variable, which is here the percentage concentration of amylase. Then you will fill in the rows. It's going to be 2 columns and 6 rows. The rows with the concentrations that you have already created in table 1.2, and the dependent variable is going to be the time taking to reach the endpoint, and don't forget the slash units, which here is seconds. So as the percentage concentration of amylase decreases, the time taking will increase, the time taking to reach the endpoint. So for example, you will get that 2.0 is at 30 seconds and 1.6 is at 75. You have to get values from these tables. Then 1.2 is at 105 seconds, 0.8 is 150, and 0.4 is more than 180 seconds. Said the independent variable in this investigation, the independent variable is, you can get it from the steps, of course, the thing that you are changing, which here is the concentration of amylase. Then carry out step 15 to step 23. You will read the steps carefully and carry them out. Put 1 drop of iodine on the white tile at each sampling time as shown in figure 1.1. Label a test tube with the letter U. Put 3 centimeter cubed of S into this test tube. Put 1 centimeter cubed of solution U into the same test tube. Use a glass rod to mix. Don't forget to mix for all the test tubes so that you will have the correct trend when finding the results. Start timing, and after 15 seconds use the glass rod. Transfer a drop of the mixture from this tube into the drop of iodine. That's label 15 on the white tile. Clean the glass rod with a paper towel and repeat step 20 to step 21 at 15-second intervals. Record in AV the time when the endpoint is first observed. If the endpoint is not reached at 180 seconds, record as more than 180 again. After making the investigation, you can get the results for you as, for example, 150 seconds. So 150 seconds, you'll go back to the table that you have drew or plotted, and 150 seconds is going to be at 0.8 percentage concentration. Using your results in AIII and AV, estimate the concentration of amylase in U. So it's going to be 0.8%. Suggest one source of error in the procedure described in step 10 of this investigation. Step 10 here states, repeat step 8 to step 9 at 15-second intervals until the endpoint is reached. Endpoint here, so the endpoint is the change in color. So suggest one source of error is it's difficult to judge endpoint by eye, and suggest how you can make one improvement to reduce the source of error stated in AVII. Use a colorimeter for more accuracy, and so that the results are not subjective. Then again, describe how you would modify the procedure to investigate the effect of pH on the time taken for amylase to hydrolase starch. So here, the independent variable is going to be the effect of pH. So you will use the same concentration of amylase and use at least 5 different pH values, and you can state them in between brackets, which is 2, 4, 7, 9, and 13. And repeat the steps shown in the first question. Question B states, a student investigated the effect of different substrate concentrations on the activity of an enzyme in the presence of an inhibitor. The concentration of the inhibitor was standardized. Then the table is given. The independent variable, which is on the left side, will be plotted on the x-axis, and the dependent is going to be plotted on the y-axis. So, concentration of substrate, mole decimeter to the power of -3 is going to be on the x-axis. You have to write it, and don't forget the units. And it starts at 0.0 and ends at 1, and you have 5 divisions, 1, 2, 3, 4, 5. So you can just write at each one 0, 0.2, 0.4, 0.6, 0.8, and 1. So all the values are going to be in the range of your x-axis. And then again here the y-axis starts at 0 and ends at 2.25. So you can make it a difference of 0.5, 0, 0, 0, 0.5, 1, 1.5, 2.0, 2.5. Of course, don't forget to state all of them in one decimal place. So it's going to be 0 0.0 and 0 0.0. Then you will plot the points. The first point is at 0 0, so you can plot it here. I'll use a different color. Of course, you will solve it in a pencil. You will draw on a pencil. Second point is 0 0.2 to 0 0.75. 0 0.75 is going to be exactly